Okay, we're going to start by going back to the breakout examples that we covered at the end of last block because I didn't multiply it out, but I thought some of you might need to see part C. Is that an accurate statement? Yeah. Okay, so plugging and chugging shouldn't be that big of a deal. However, some of you may have struggled with the simplifying, which is really what I wanted to cover. Okay, so plugging and chugging. Again, as a quick review, just for giggles, what is f of smiley face?
Smiley face squared plus 7.
Good. Okay, so whatever it is, you plug it into the function. So f of x plus delta x would be x plus delta x, quantity squared, plus 7. And I know I wrote this out last time, but I wanted to simplify it for you. Plus f of x, which we already know, all over delta x. Okay. By the way, this is called a difference quotient, and we'll work a lot with it in this class. Have you seen that before in pre-calc? Okay, good. Then your calc teacher or your pre-calc teacher helped me out here. Quick side note here. Let's talk about x plus 1. If I asked you to multiply that out, how would you do it? Push. Okay, so that's how I do it too, but I wanted to see how everybody does it. So some of you might write that as x plus 1 times x plus 1 and FOIL it. That's fine. Some of you might use the formula. The way I do it is using a weird version of the formula, and that is I take the first term and I square it. I multiply the two terms together, then double it. X times 1 is x, times 2 is 2x. Square the last term. Done. Okay? Again, square the first term, multiply the two together, double it, square the last term. Using that here, square the first term, multiply the two terms together, and double it. Square the last term. Yes, you can have delta x squared. Plus 7. Distribute the minus sign, minus x squared, minus 7. And that's why the parentheses are so important, because it's going to allow us to cancel some stuff. Okay. So the 7 goes away, the x squareds go away, and if we've done it correctly, you'll notice that each of those terms have a delta x. And I'm going to do it the traditional nitpicky way. Most of you would just cancel all the delta x's and go from there. However, as things get more complicated, you probably want to get in the habit of taking delta x out of each of those, and then canceling. And so our final answer becomes 2x plus delta x. Okay, any questions on that process? That is a very basic concept, but crucially important in calculus. So again, I wanted to make sure on day 2 that you could all simplify that, because we're going to have to be able to simplify that ad nauseum.
So when I use like delta x squared, I first wrote that as like delta squared x squared, but like should it like...
It should just be delta x. Delta x is one term.
Yeah.
Yeah. You don't distribute the squared to the delta and then to the x.
Okay.
Okay. Any other questions before we move on? Okay, so then we left off with the speed round. We did that, right? We graphed that? Okay, good. We did the rule of 4. Not a big deal. We talked about the linear equation. Yeah. So I think we're here, yes? Okay. So, speed round. VLT, vertical line test. We talked about that already, but a quick repeat. Anytime you can draw a vertical line through a graph and it hits in more than one spot, it is no longer a function. Okay. So for every one x value, for every one y value you could, for every one x value you can only have one y value. Sorry, said it backwards, because we'll get to HLT later. Symmetry will sometimes help you with graphing. You know what symmetry is, yes or no? Yeah, so you can have x-axis symmetry, that's top and bottom. You can have y-axis symmetry, left and right. You can have origin symmetry, which is upside down, right side up. We'll talk a little bit about that later when we get more in depth into functions. You all know what the graph of the absolute value of x looks like. Has anybody ever explained to you why it's a V? Via.
It's both like a positive and negative. Like it could be any of the values.
Keep going.
Like
You haven't sold me on it yet. You guys didn't grab your name tags, did you? Could you come and grab your name tags real quick so I don't have to point at you and try to remember your names? Of course, I'm not going to forget Margaret, Maggie, May. That's a good Southern name, by the way.
it is.
Margaret, Maggie, coming for dinner now. We got stew on, pass the cornbread. All right, May, what do you got for me?
It's because like it can't be as below. Like you can have like an x value of negative, but the output would be always positive. So if you got the negative of an x, then it would always be positive. So it has to go up.
Okay, so let's compare these two things. Let's compare that versus this. What's that look like? Yeah, it's just that 45-degree angle line that would come through like that. So based on what May said, the absolute value then, when we start to talk about the absolute value takes all the negative values, okay, takes all the negative outputs, takes all the negative y values, and makes them positive, which is what I think you were trying to say, right? Yeah. In other words, it takes this part of the graph and flips it up. Does that make sense? Okay, good. Because later on, we're going to talk about how to graph some not pretty absolute value functions. In other words, and I don't know if you did this, but I'm thinking in pre-calc, for instance, you graph something like that. You could graph that, yes?
Yeah.
What does a 2 do to it?
Moves all of the values over to
Which way?
the right. Left,
To the left?
I think, right?
I don't know. Which way, left or right? You think left. He thinks left too, but I need to know.
Or is it left toward the negative plane?
One of the.
It goes left.
Okay, yeah.
Okay.
And it's outside. It goes. Oh, right, because if it. Never mind. I got it.
Where's that go?
2 up.
2 up. Right. And so you've talked about transformations, yes?
Yes.
Okay. In other words, we're taking this basic function of absolute value. So you take that v and you move it around. And then I'm sure you did some scrunching and some stretching and all that business, right? Okay. Did you ever do anything like this? Okay, we're going to get to that later. Yeah. Or something like this.
We like made it like wider somewhere, remember? Yeah.
So we're going to take some weird, not weird, that's a regular just plain old quadratic function. It's a thank you, I've been on summer break. We're going to take a parabola and we're going to figure out how to take a parabola and get it to graph with the absolute value. That's for later, but I just wanted to give you a brief introduction here. So now you know where that comes from. Okay. It seems to me like somebody should have explained that to you at some other point in time, but since they didn't, we'll just pretend that that they did and move on. Okay. You probably just learned the absolute value of x looks like a v, and then you went from there and moved it around and did all that other stuff. Increasing versus decreasing. If I get rid of this mess here, and we go to the basic graph of the absolute value of x, where is that absolute value of x increasing? 0 to infinity. Where's it decreasing? Is that a simple concept? It's increasing where the function's going up, it's decreasing where it's going down. Always moving to the left. I mean the right. To the right. You know that trick, right?
Mm-hmm.
This is an L, so it's left.
I just remember my watch is on my right hand.
You remember what?
I just remember my watch is on my right hand.
My watch is on my left hand.
Yeah.
Are you left-handed?
Yeah.
I'm left-handed also, though.
Interesting.
Yeah. I could explain why that happens, but we don't have time right now.
Okay.
Odd, even, or neither. Remember, yes? How do you determine if a function is odd? And I don't mean odd like weird. I mean odd like mathematically. Oh, tell me more.
Like, it's X.
Okay, so let's go back to this guy. Even or odd?
No, it's odd because the two.
There's
Oh, this is
Neither.
Neither. Okay, let's start with the basics. Even or odd? Or neither?
Even.
Even.
Okay.
Oh, I
Hold on. Even or odd or neither?
remember.
Odd. Oh, let's get saucy here. Even or odd?
Neither.
Even?
Neither.
Who said even? Was it one of you two? Oh, back there. Allie. You said even?
Yeah.
Why?
2 squared.
No.
4 is
I mean, yes, 2 squared is 4. I'm not denying that, but that's not why it's even. You are right, it's even.
Isn't it just an even number here?
But why is just a number even?
Because it's divided by 2. Divided by 2.
Okay, let's forget about the 4. We're obsessing on the 4.
Wait, it has
7. Even or odd?
even.
Even. Okay, you're thinking even and odd like the
Right.
number.
Right.
Yeah, because 4 is divisible by 2. No, not that. We're talking about functions. This is a function. Is it even or odd? It's even. The reason it's even is because that's the same thing as x to the 0. Right?
sure.
And 0 is even.
Isn't 0 neutral?
It's even for our purposes.
Okay.
Is it something with like how many binomial, trinomial things you can break?
When you're
into?
talking about polynomials, the function is odd, even, or neither if all of the exponents are the same. Okay, so this is even because all of the exponents are even. This is odd because all of the exponents are odd. This is even because all the, okay, this one was neither because we've got even, and odd. Okay, and we'll talk later about how we can also determine this graphically. And this is a very niche thing of only when we're dealing with polynomials. Not everything we do in here deals with polynomials. Pregunta, senor?
Yeah, so it wouldn't matter how many even or how many odd, as long as you have one of each, it's neither.
No, as long as it's consistent across. So if I have x to the 8th plus x to the 6th plus x to the 4th plus x squared, even. X to the 8th plus x to the 6th plus x to the 3rd, neither. Okay, all even, all odd combo determines even odd. Okay, and again, we'll talk about pictures later. The way my brain works, it's kind of a scary statement, but I'm a very graphical person, so whenever possible, I'm going to try to sketch a graph and work with the graph. We'll see how your brain works and get you to where you need to be. We're going to skip this because we needed it yesterday. We just started, so we don't need a kinetic activity. But transitioning now into mother functions. What are the mother functions? Can you give me an example of a mother function, I guess would be the question. Go ahead.
Y equals x.
Y equals x is an awesome mother function. What kind of mother function is that, Nathan?
It's a line.
Good. Also known as a linear function. Good. Other mother functions.
Y equals X squared.
Good. Known as a?
Parabola.
Known as a?
A quadratic.
Right, this is a quadricept. Right, got it? That was a
Yeah,
stretch, but I knew
I
you'd get
think
there.
it's
Or did you hear somebody whisper it?
No.
Okay.
I just knew it.
You knew it, right? Okay. So we got linear, quadratic. Keep going.
Y is equal to the thing, the x in the lines. The
Absolute value.
Absolute value.
That is a mother function, yes.
Y equals x cubed.
Also known as a
Cubic.
cubic. Good.
Y equals the square root of x.
They're on the slideshow, aren't they? Oh, jeez. I forgot to
Oh.
delete those. All right, I'm just going to click through this. Here, I'm thinking you guys are so smart, but you can read at least. Cubic, quartic, quintic, hextic, heptic, octic. We're not going to get anywhere near that. Seldomly do we do anything more than a quintic, which is degree 5. Absolute value, semicircles. Why semicircles? Why? whole circle.
Oh, because circles aren't functions.
Circles aren't functions. Very good. Doesn't pass the vertical line test. Exponential functions. Exponential functions are always the depressing ones. They involve death and destruction, spread of disease, zombie invasions,
Falling from a high place.
falling from a high place.
Yeah.
Oh, okay,
Yeah.
Because you like how far.
Exponential goes up. I didn't,
Oh yeah. Okay.
yeah. There are. We'll get to those in a
Well,
second.
it could be velocity graph.
It could be. It could also be an acceleration.
Yeah. It's
Okay.
one of the-
Square root function,
Yeah.
reciprocal function, 1 over x. Real simple. Any others we didn't name or you didn't read to me off the list? No? Well, you got your logistic graph. You got your logarithmic graph. Logistic, very interesting. Logistic would be something like growth of natural objects follow a logistic. If you think about if you were to plot your height over time, you would get a logistic graph. Climbs very quickly, starts to level out. Technically speaking, for most humans, it's not a true logistic because what happens when you get older? You start to shrink. Yes. Hasn't happened to me yet, but it will soon. We don't do a lot with logistic graphs. We do some work with logarithmic graphs. Oh, and there's actually 5 big ones I didn't list. 5 big ones? 4 big ones? 6 big ones. No? Trigonometric graphs. Sine, cosine, tangent, secant, cosecant, cotangent. Please tell me you did graphing of trig functions last year.
Yeah.
Yeah.
Awesome. We don't do a lot with it in here. We will review on day 3 with that. No? Today we'll review that. Oh, that'll be fun.
The one thing I'm good.
Oh, excellent. So this will be it. This is your swan song. And then everything's downhill from that point on. That's so sad. Do I need to talk about slope? Okay, good. Confirm that we don't have to talk about slope. Could you calculate the slope of AB, please? Just to make sure we don't make any sign errors. Or you flip it over. Kind of stuff.
Should it be a decimal or?
No, leave it in a fraction, please. Haley, what do you got?
-5 or 8.
Can somebody confirm?
Yeah.
You got positive?
Never mind. I messed up my sign.
Yeah, but you're gonna be okay, right?
Yeah.
Mistakes are encouraged, right? Growth mindset.
Yeah,
Yeah, do you need to go see your counselor?
I'm okay for
All right, good. That's what I like to hear. Haley, did you do 7 minus 12 or 12 minus 7?
12 minus 7.
Does it matter?
No.
No. Any reason why you put the 12 in the front?
No.
Okay. M, slope. Yes? Do you know why?
This S was
Because they
taken.
ran out of letters.
Nobody really knows. Big math arguments about why the dudes that did this chose M. Some people argue that the French word for mountain starts with an M. Others argue there was a randomly picked number or letter. I don't care.
French word for mountain. Mountain already
Well,
starts.
but they were probably French.
They were French.
Yeah. But it's the same. Yeah.
So probably there's probably somebody in France right now teaching calculus saying they use M because the English word for mountain starts with M.
Yeah. And then-
Haley, what's the slope of any line perpendicular to that line?
8 over 5.
Good. How do you do that?
You take the reciprocal and it's like the opposite side.
Yeah. The flopposite, if you will. How about parallel?
Negative 5 over 8.
Good. Okay. Hi, welcome to Algebra 1. Oh, Haley, is it 5 over negative 8? Or is it negative 5 over 8?
5 over negative 8.
Has to be 5 over negative 8?
Yeah.
Are you sure? You like this though, right? What if I like this?
It's the same.
It is. Okay. How about this? They're all the same, yes?
Yes.
Good. Why can't my freshmen learn that then? I know you know the answer to this question, but being able to answer it in a mathematical aspect might be a little difficult. However, you have the formula on your slideshow right in front of you. But that formula doesn't actually tell you what it is. What is a polynomial? So, I mean, you could read off to me that, which doesn't even look like it's written in English. It's not, it's just a bunch of letters. But if you were sitting at the dinner table, Mandy, do you have any little brothers and sisters? No. Allie, do you?
Yeah.
How old?
13.
13. Okay, 13 would work. So you're sitting at the dinner table tonight and you're talking to your little
Yeah.
brother, and he says, "Hey, Allie, what's a polynomial?" How do you explain it to the 13-year-old? Not so easy to do, yes?
Yeah.
You can all give me an example of a polynomial, yes? Defining what a polynomial is becomes more difficult. Does a polynomial, so according to this formula, what does A stand for, by the way? It's a constant. It can be anything, okay? So this notation is a little deceiving. This makes it look like you have a constant with a sub number. It doesn't matter. It's just a constant, and it changes. Can it stay the same? Yes, you know that already. So let's forget about the A's. Make those go away. Let's focus on the variables. Do the variables have to reduce as you go along? In other words, we all agree, I hope we all agree, that that is a polynomial, yes? 3, 2, 1, 0. Okay. What if this goes away? Is it still a polynomial?
Yes.
Yeah, okay. So this formula, I'm erasing here. This fancy schmancy formula makes it look like you need each one of those descending exponents. You don't. So instead of trying to define a polynomial, let's talk about what's not a polynomial. Can someone give me an example of something that's not a polynomial?
One number.
I was about to say I.
One number? Can I pick the number? Is that a polynomial?
No.
It is, actually. Remember?
Oh.
Oh.
Good try, though. Somebody said, you watch your mouth in here, mister. We're not bringing that imaginary crap into this classroom. You are right, in fact, though, that is...
Yeah.
Well, okay, hold on. It's not a polynomial, but is it a function? We're going to pretend you didn't say that.
Well, it's hard to graph because it doesn't exist. But,
Well, you have to graph it on an imaginary axis
Yeah. Okay.
in your imaginary brain, in your imaginary math class, knowing that it'll never exist. So let's spend a quarter working on it. Let's promise never to mention it ever again. Any other ideas?
0.
No. Actually, yes. Wait.
So we were traumatized by the eye for nothing?
Bring it up.
Don't bring it up.
It that shall not be named.
What if it's like
Yeah.
x to the power of like a negative number, so it's like a root?
Ooh. Is that a polynomial?
It doesn't. It exists, but it's not.
What kind of whoa. That was supposed to be a 2. Shh.
Sorry.
Not everybody's perfect. What kind of function is that? What's that called?
An inverse function.
What's that?
An inverse function?
Technically it's an inverse function because it's a 1, but there's a more global name for that type of function. Rational function, close enough. It's a rational function. Okay. It's a ratio of 2 functions. Okay, more commonly, it's easier to see a rational function of something like this. Okay. Function over a function. Okay, so what does a polynomial have to have? It has to have positive exponents, and those exponents must be whole numbers. In other words, you can't have x to the 1/2.
Can you have that? Or you, no.
You all know that that's the square root of x, yes?
Yeah.
Okay, good.
Oh wait, I totally said that negative exponents were like roots, didn't I? No, that's not right. Yeah.
Rational. Okay, good. So that took 20 minutes, even though we all knew what it was. Okay, we're done. Questions? Beautiful. We're going to transition into today's lesson, which is a quick review of trig, and then we'll be done. Before I forget, however, I sent you out a Schoology blast about the AP join code. If I remember correctly, only one of you has not taken an AP test, right? Is that you, Liam? Okay, so you should have, help me through this because I never do it as a student. You should have like your own little AP
It's like mine.
like login or something or another, like your classroom.
Yeah, you have to make it.
Yeah.
Yeah.
So basically set up your login on AP Central and it'll ask you to join a class. I sent the code out in Schoology. Please do that as soon as possible. By the end of next week, I have to make sure that the people in the room match the people in the class. Especially if we start doing there's a lot of good lessons and stuff on AP Classrooms that I might be sharing with you, and you can't get it if you're not enrolled in the class.
Where do I put in this?
You have to go to the AP website. I think it's AP Central something or another.
I just always go to College Board.
College Board, yeah, they're the same place.
Yeah, it is the same
Yeah.
thing.
By the way, for those of you that didn't get it, the code is DYEPJD. Donkey, yak, elephant, puma, jaguar, dog. Okay. And you don't necessarily have to do that now. You can do that at your leisure. The number or the code is in Schoology, so you can always go look that up
Use
on.
your school email to log into it?
Yes,
Okay.
you must use your school email to log into that.
I think it's your old
Wow, that's horrible.
That's major. You make your own password.
What in the heck happened there?
But when you made it freshman year, what was your Have you made an account yet?
You have to make an account first. Yeah. And again, you could do. There we go. That's better. You can do that at your leisure. What is that? It's the unit circle. Yay! For those of you that want to play along at home, hold please. That graphic is available in the Chapter 1 folder. How many of you feel right now, if I gave you a unit circle quiz, you could ace it? How many of you feel you could do okay? How many would just start to cry and want to go see their counselor? Okay, good.
Wait, no,
You need to know the unit circle. The problem with the unit circle is that there are a lot of different ways that people have learned or will learn the unit circle. There's a lot of different ways that people work with the unit circle. Okay? So for instance,
We graduate in May.
I'm sorry?
We graduate in May, right?
I don't know, I don't graduate.
No, but, okay.
We did.
Okay.
Where was I? Oh, so how to operate the unit circle. Some of you may have just gone last year and memorized the unit circle, and hopefully it's still with you. Some of you may have learned a process to solve problems on the unit circle. It's entirely different for each person. So Dimitri, if I asked you what's the sign of pi over 4, would you be able to answer it?
Probably. It's the square root of 1 over 2.
Well,
Well, just 1 over root 2. Yeah.
there you go, 1 over root. Are you, by the way, are you guys 1 over root 2 or root 2 over 2 people?
Root 2 over 2.
Whatever, too.
I'm a 1 over root 2 guy.
Yeah.
So that's, I'm sorry, Nate.
It's weird that that's the same.
You gonna be okay? You gonna be able to manipulate that?
Maybe.
So Dimitri, back to you. How did you know that was the answer?
It's the values of the triangle. And also it's about 45 degrees.
So you're using the triangle method.
Yeah.
Excellent. All right, I'm gonna show you the method that I use. Well, first of all, we're gonna build the unit circle. You're never gonna do this, especially on the AP test. You're not gonna have time to do this. But it is important, I think, to see how the unit circle comes about. And then I'll show you some ways that I use to solve the unit circle. Maybe it'll help you, maybe it'll confuse you. But I will say, you need to be able to work the unit circle inside out, outside, forward, backward. You need to be able to find all 6 trig values for all the locations on the unit circle. Okay, so I'm going to focus just on quadrant 1. Is it safe to assume that if we review quadrant 1, y'all could find quadrant 2, 3, and 4? If not, I'll do the other ones too, but I'll show you how I do quadrant 1 and then we'll move on from there. By the way, everything in here, 99% of the time in here, we're in radians. Your calculator in here should be in radians. Who's in physics right now? Yeah, that could become a problem because I think in physics you're in degrees, yes?
Yes.
You don't know yet.
You are.
Probably.
There you go. Just smile and nod.
Yeah.
There you go. Good. So I will remind you as time goes on, when we sit down for the first calculator quiz, I will remind you to make sure your calculator's in radians. The AP test has that reminder all over it. Every other second you're picking up a calculator, they're reminding you in radians. So I'm not even going to bother with degrees. Some of you might, your operating procedure might be to convert degrees to radians. I'm not going to do that. Okay, so here's how I start. I know that this is not a good technology day for me.
That's a thing, I think. Like, it's meant to like highlight.
Hold, please. I'm so happy I'm recording this.
You can always stop.
Never stop. Never surrender. Come on, baby. Here we go. Here we go. It's going to work this time. I'm feeling good. Right? Right?
Yep.
0.
Yay!
I did so much. Comma 2 pi. Okay. If somebody handed me this as a quiz and I had to do the whole unit circle, I would start with the following. I would start with pi over 4s and go around the circle. Pi over 4. Whoops. Try that again. That's a 4. 2 pi over 4, also known as pi over 2. 3 pi over 4. 4 pi over 4. 5 pi over 4. 6 pi over 4. Also known as 3 pi over 2. 7 pi over 4. Back to 8 pi over 4, which is 2 pi. Can you see that green, by the way? Is it okay? The way V is squinting at that, I'm going to say no, and I'm going to switch to red. Okay. All right. Then I go by pi over 6s. And pi over 6s will fill in the rest of the unit circle.
Is he coming out with
pi over 6. I already did the pi over 4, so I go to the next one. 2 pi over 6, also known as pi over 3. Got that already. That's 3 pi over 6. 4 pi over 6. 5 pi over 6. 6 pi over 6, I already have it. 7 pi over 6. 8 pi over 6. 9 pi over 6. 10 pi over 6. 11 pi over 6. 12 pi over 6, also known as 2 pi, so then 2 pi over 3, cleaning things up a little bit around here. 4 pi over 3, and 5 pi over 3. Okay. So now I have all the locations under control. That's the easy part. Are we good so far? This is easy, right? You're with me? Okay, so now I'm going to show you how do I solve something like the sine of pi over 3. Okay. I know this. There are only a finite number of answers for the unit circle. My possible answers are 0. You tell me. What are the possible answers? Possible values of the locations. Nathan.
Root 3 over 2.
Root 3 over 2.
1 over 2.
1 over 2.
Root 2 over 2.
Also known as 1 over square root of 2. And 1. Okay. We're going to exclude, and the negatives, but I'm not going to bother. We're going to forget about those. I'm assuming you're okay with the 0 pi over 2 pi, 3 pi over 2. Is that a safe assumption? Good. So let's focus on the other guys. Hey, Nathan, back to you. In numerical order, which one is smallest to which one is biggest?
1 over 2, 1 over root 2, and then root 3 over 2.
Okay, small, medium, large. Get rid of that so we don't get confused. Okay. I use that to solve the problem, which is a variation of what you talk about, Dimitri, with the triangle problem, right? So if I'm solving for the sine of pi over 3, I'm coming to that point. And in order to get to that point, when I go from the origin, I'm going to change colors here. I'm going to go over and up. So I'm traveling along the x direction, and then I'm traveling along the y direction. Since I'm not on one of the red lines, I know that I can forget about this guy. That only works for the red. That's only the 45s, if you will. The pi over 4s, if you will. In that picture, which one's bigger, x or y? Y, right. So the way my brain works, and I don't know if this makes any sense to you, is I say to myself, if I'm going to pi over 3, I go in a short direction along the x, big direction along the y. Short direction along the x, long direction along the y. Before I go any further, does that make some type of sense? A little bit, maybe. Now, again, so if you're a memorizer, don't worry about it. Just do what you need to do. That's not right. What did I do wrong?
The sine is.
Oh, I'm an idiot. You can tell I've been on summer break too. By the way, how long were you going to let me go before you corrected me?
I don't know what was wrong with that.
The whole class. Whole class.
What's wrong with that?
Whole class. Oh.
What? Hold on. Let's. By the way, I meant to do that because I'm just testing you. What did I just do? What trig function did I actually do?
Cotangent.
Actually, tangent.
Oh.
No, it is cotangent because it's x over y. Okay. I didn't even consider the sine. I just went crazy on the pi over 3. What is sine?
Y.
Opposite over hypotenuse. How long is the hypotenuse in the unit circle? 1, because it's a unit circle, 1 unit. So let's try that again. Opposite is y. The y is long, so it's the square root of 3 over 2 over 1. Okay, but again, we're all smart and... Okay, a little bit of redemption there after a major full pop. What's the cosine of pi over 6? Ellie, are you raising your hand or just
Yeah.
go?
Root 3 over 2.
Also root 3 over 2. To get to pi over 6, long x, short y. Cosine is adjacent over hypotenuse. The adjacent then is the x, which is the square root of 3 over 2 over 1. But again, we're all fairly bright enough to do that. Question? Yeah, take it fast with you. It's right here.
Because no, she literally scuffed it.
But now it's quite hard to miss.
No problem. We good? Now, again, I don't know if that's going to make any sense to you and if it's going to help. If it helps, great. If it doesn't, then use whatever method you learn that's going to help you answer the question. But you need to be able to answer the trig values for all of those locations for all 6 trig functions. So no matter where you go on that graph, let's pick something random here. Let's go 7 pi over 4. You should be able to tell me what the sine, cosine, tangent, cosecant, secant, and cotangent of that location is. Okay, and then later on we're going to do inverses going backwards. But for now it's just practicing the unit circle. Okay, good? Questions before we move on? Okay, what if it's not on the unit circle? Like for instance, what if I tell you by the way, what is that?
The Jesus fish.
Yes. Yes. Jesus makes a big appearance in calculus a lot.
What's it? Does it have a name? Is it Greek?
Theta.
No.
Oh, that's theta.
Theta.
I forgot this. I don't know Greek letters.
Oh, you'll get to know them, don't worry.
Is it a Greek letter?
It is a Greek letter. It is an alpha, yes.
I don't know Greek letters.
How do I know that?
Just
I know, hold on.
quick sidebar. Alpha, beta, gamma, delta, epsilon. That'll get you started for a while. Lowercase delta.
Oh,
Uppercase delta. Yeah. You got uppercase and lowercase. So before we solve this, let me ask you a different question. Get rid of this. Let's do this one.
Oh. That's so hard.
Nope.
I think it's epsilon. No, epsilon's the. Is it gamma?
What's the giant say when he smells an Englishman?
Oh, it's phi.
Phi.
Or phi, but not full or false. That's a phi. If I asked you that question, you could do that, yes? Where is the sine of some function, of some angle called phi equal to 1/2? Well, we come back to the unit circle, if you want to use the unit circle, or maybe you do it in your head, and we see where is the y value on this function small.
Pi over 6.
Bingo, pi over 6. And
5 over 6.
And
5 pi over 6.
5 pi over 6, correct. So remember, when you start going backwards, you're going to get multiple answers. We're all good on that, right? Okay, so we go back to this now. So this would be phi is equal to pi over 6 or 5 pi over 6. Easy peasy, still lemon squeezy. So we come over here, and now this. There is no negative 9/13 on the unit circle. So we have to be able to figure out where that occurs. How do we do it? You know, Dimitri knows.
Inverse cosine on both sides
Ooh. And how would you find that then?
with the calculator.
Good. Okay, so if we had a calculator, you're 100% correct. You'd plug the inverse cosine of negative 9/13 into your calculator. Love it. We ain't using a calculator.
Give up, cry, call your counselor.
I'm sorry, what?
Give up, cry, call your counselor.
In that order?
Yeah.
You wouldn't cry first and then give up?
Actually, yes.
Okay, all right. Well, that's fine.
Like a triangle.
So we're going to take what we did on the unit circle and transplant it into just a triangle. There's alpha. I always put it down in that corner. Where does the 9 go? Where does the 13 go? Nathan?
The 9 is the like adjacent side, and not the hypotenuse yet. And then the 13 is the hypotenuse.
What about that guy? You want to deal with that later or deal with it now?
I don't really.
It's up to you. There's no wrong answer. Which one would you prefer?
No.
Now, okay, now we're going to cheat. We're just going to put a negative sign there, which makes no sense because now I've created a negative distance, but roll with it. It'll be okay. How do I find x? Pythagorean theorem. X squared plus negative 9 squared equals 13 squared. X squared is equal to 169 minus 81. Quick. 88? Did you say that, Kush?
60.
Tell me how you did that.
9 minus 116 minus 8.
So you did it like you set up the picture in your head of 160, and then you did the whole. Okay. I have some good news for you. Guess what we don't do in calculus?
Simplify
We don't simplify a radical. Guess what else we don't do in calculus? You're going to love this. This is an okay answer. Yeah. We don't care about rationalizing denominators. It's a waste of time. Plus or minus? Huh. Well, which one is it?
Well, isn't it really
Where
possible?
is this triangle happening?
It's in the second quadrant.
Second?
First?
Yeah. It should be
Yeah,
positive.
second.
Second?
Second or third.
Second or third?
Yes. Because the x is negative, right?
Well, which one? Second or third?
Couldn't it be? Yeah, it doesn't say, it just says it's on this side of the graph. Like it's like that on this side.
Well,
But it could be.
I'm not disagreeing with you, but I am asking which one, second or third?
Just choose.
Whoa.
Just choose one.
Second.
You're right and wrong. How many answers did we get over here?
Oh,
Two.
Two.
How many answers are we going to get here?
two. So
Two.
it's
So this becomes the square root of 88. Now that you have that, I'm not necessarily going to ask you to find that in this type of problem because we don't have a calculator. I have no idea how big that angle is, but what I do know is I can answer all kinds of questions about that triangle. Like, for instance, okay, now let me clarify. In this type of problem, you'll see two variations. One variation will be like this, and I'm working through with you where you have two answers. Other times, what they will say is, there is an angle such that the cosine of alpha is equal to negative 9/13 in quadrant 2. Or, like you said, quadrant 3. If they don't specify the quadrant, you've got to give both answers. If they do specify the quadrant, then you only give one answer. So let's assume, for discussion purposes, We're in quadrant 2. Should this be positive or negative?
Positive.
Positive. I shouldn't have used X, by the way, because that's a little confusing. Let's pretend this was a K. K doesn't get enough love. So if we're in quadrant 2, the value of K should be positive, and therefore the tangent of alpha is equal to
Square root of 88 over
square root of 88 over
-9.
negative 9. Good. Once we've created a triangle, we can go and work with any one of the other 5 trig quantities. We could do secant, we could do cosine, we did cosine. We've done cosine tangent, we could do sine, secant, cosecant, and cotangent. And you know those are all reciprocal functions, right? Beautiful. We good? Nathan, what time do we say we're out of here? Is it 10? 2:10. Okay, I gotta pick up the pace a little bit. Please explain to me quickly how your teacher taught you to graph trig functions. Was it memorization? You just remembered what the sign, you memorized what the sine graph looks like? Does the 5-point method mean make any sense to you? Yes?
Oh, yeah.
Okay, so that you're all familiar? No? You look confused. Okay, so here's the theory between the 5-point system. The 5-point system says that every trig function relies on 5 points. So if I'm graphing the sine function, for instance, the 5 points I need to know in order to graph a sine function, sine of theta, would be the starting point and the ending point, then the middle point. And we all know that the middle point is exactly in the middle, yes? So if this is at 0 and this is at 20, where's the middle point? 10. So it doesn't matter where the starting and stopping points are, you can find the middle point by taking the average, right? Halfway to halfway, you can find that location. Does it go up or down? Goes up. How far does it go up? Just one. We're just doing the basic sine graph. Halfway to halfway goes down to -1. Draw your curve and make it a curve, not V's, and you're done. Okay. All of them come down to 5 points. Cosine starts high, ends high, halfway it's low, halfway to halfway you're on the x-axis. Tangent is a little bit of a cheat there. 2 of your points are actually vertical asymptotes. Halfway to halfway is the middle point. Go up, go down, you're good to go. What if I want to graph? We'll do the reciprocal function. How do you graph the cosecant? Question.
Just draw on the points on top.
Good. What goes here at these 3 points? Asymptotes. So take the sine graph. Wherever there's a hill, you do it up U, and wherever there's a valley, you do it down U. Starting point, ending point, middle point have asymptotes. Up U, down U, good to go.
Is that cosecant or right?
Cosecant, yeah, the reciprocal of sine.
Wait, why is it CS?
It's not. I wrote it wrong
Oh, okay. Sorry.
because I invented my own function. Kind of a big deal. And again, I don't want to beat a dead horse because you did a lot of this last year and it's not that crucial for us. You'll practice it a little bit. The key to all of these is finding the starting point and the ending point. Did you practice things like that? Yeah, so that looks familiar, right? You take this puppy and you put it between 0 and 2 pi. You solve for x. That tells you where to start and stop. You remember that, right? Yeah, we're not going to get into that many things that intense, but I just wanted to make sure you heard it from me so that if we have to come back to that, we're all on the same page. Okay, one last thing and then we'll be done, and that is solving trig equations. Now, we're not going to get to that today, so we'll come here. I said solving trig equations, not trig identities. Did you do trig identities last year? Yeah, we don't care. Okay, we're solving trig equations. Something like this.
Yeah, identities.
Oh, I hate it.
It's like something minus the other one.
Sine squared minus.
Yeah,
Now you might be saying to yourself, self, easy peasy. I'm going to divide everything by sine. Why is that bad? Who's talking? Is that you?
Yeah,
Liam?
it gets rid of the answer, right?
Correct, you lose an answer. So first major rule, never ever divide by anything unless you're 100% sure that it's not equal to 0. You can divide by 7 all you want. You can divide by a gabillion as much as you want. But as soon as that thing could possibly be equal to 0, you can't divide by it. So the question is, how do I solve this? Hey.
make sine squared 1 over cosine.
Ooh, I didn't think of that.
Cosine squared.
Oh, okay, I'm going to do that in a different color. You can have the left side of the board. 1 minus cosine squared theta minus sine theta equals 0.
I did. I said.
Then what?
I did.
You just started mumbling there. Did you panic?
Yeah.
It's okay, I make mistakes too. Why is this not going to get you where you need to go?
Because now you have the two, like, now you have both cosine
Yeah.
and sine.
If there was a way to nicely convert sine to cosine, but there isn't, so, okay. I'll take the right-hand side of the board. How else do you do it? Okay.
You could factor out a sign.
Bingo. Okay. Sine theta times a quantity, sine theta minus 1 equals 0. Next major rule. What is the zero product rule?
They all equal 0.
Now you're going to need to be more specific than that.
They could all equal 0.
If A times B equals 0, what does that tell you about A and B?
One of them equals 0.
One of them 0. Do we know which one?
No.
No, so what do we assume?
They both could be.
They're both 0. Oh, look, 2 answers. If we would have divided by sine, we would have lost one of those answers. I'm going to let you, I mean, you can figure that out, right? Good. Okay. Questions?
Wouldn't both of these be no solution?
What's that?
Wouldn't both of these be no solution?
No. Just right, like, it's one of those.
Or what if we were trying to find theta, that is, so.
Sine relates to y, whereas y equal to 0 on the unit circle.
Oh, no, never mind, just the one. is-
Actually, you have more than 2 answers. You'll have 4 answers.
Not thinking.
Okay. Yeah. Tonight's homework is a little confusing. There's a PDF attached to the assignment. It's not in the book. And I gave you this big, long appendix packet. So you're saying to yourself, as you're scrolling through to find where the actual problems are, you're going to be saying to yourself, Self, why did you give us all this garbage? Why do you just get rid of all these other pages? Because those other pages have a lot of good information. It's a good, I guess, reference to have for things like if you forget how to do interval notation, if you forget some basic geometry facts, it's in that appendix thing. But don't go to the first set of problems and start solving it. You'll see on the assignment today it says in C3, cat trace. Okay? Go to that section and solve the problems there. You should be doing trig problems. If you're not doing trig problems, you're not in the right section. Okay, we good? Our first quiz is on Thursday. So all of this stuff will be due next Thursday. On, when do I see you again? Tuesday, when everybody's back and we're all one big happy family. We will spend some time going over the day 1 homework. We'll spend some time going over the day 2 homework, which is all the trig stuff. we'll take a look at some autobiographies, and then I'd probably have another lesson for you there, all wrapped up into one big fun period. Okay? Again, remember, stuff isn't due till Thursday, but we're only going to talk about day 1 on Tuesday. Sorry, everything is due Thursday. Yeah, I said that right. So you should take a look at that. If you haven't already finished day 1, you should be able to finish it now. But I think even based on the little bit that we talked about 2 days ago, you should have been able to finish the day 1 homework because it's all just review. Okie doke. Questions for me?
Where exactly is the document?
I haven't unlocked it yet.
Oh,
Yeah.
10 minutes.
Give me 10 seconds and you'll be good to go. No internet. Great.
Like that.
Okay, there you go. It's attached to the day 2 homework.
No one's getting